Hello? Is the mic working? Can everybody hear me? Is everybody comfortable? You got the right seat for this talk? I hope you had a good morning, that you had a lot of food for thought, that you also got some nice food at lunch, and that you're not here just to digest that and go to sleep and take a nap. And I'm going to try and get the next slide. There we go. Sometimes I look like that. It's very rare, just to reassure you. My name is William Bartlett, and before I get to the rest of who I am, I'd like to get to know you. Now, there are a lot of you. Actually, I thought there wouldn't be very many of you, so I'm pretty excited at how many people there are. And so what I'd like to do is just do a quick survey to get an idea of what kind of people, what kind of profiles there are in this room. So raise your hand if you're in IT. Okay, good amount. Okay, raise your hands if you're doing microservices, if you're working on microservices. All right? Are they fun? Are they cool? You got a smile because you're doing microservices? Okay, raise your hand if you're doing back-end microservices. All right. Now raise your hand if you're doing front-end microservices. There are fewer hands. There are fewer hands because this is a very hot topic. And so today I'm going to talk about full-stack microservices, but especially what we're missing to attain that. And I think that what we're missing is a key element in the front-end area, but that kind of completes the puzzle. So we will talk about the full stack side of it, but there will be a good part on the front-end elements. So a bit more about me. I consider myself a level 23 programmer. I started at the age of 10. My first programming book was C programming language. I got to about chapter 4 pointers, and I was like, whoa, that's too complicated, so I waited. But now I understand that, and I've gone on to other things. I work for TREEPTIK as an agile coach, and I'm also a Java developer, and I'm a container enthusiast. You know, Docker, yay. Kubernetes, yay. On the side, I'm also a web component nut. I got very interested in web components years ago. It was like, to me, it was like the missing thing in the web. And it was very frustrating that not many people were just as convinced as I was. I worked a lot with using Polymer for web components, and we'll see a little bit more of that later on. I also want to mention that before coming to TREEPTIK, years before, I was a doctoral candidate. And I mention this because that's where I started doing presentations. I would have to present my work regularly to the team, to other teams in the lab, and to other labs. Sometimes we get together, several labs, and each team would present their work. And one key element is that they would present related work. They would say, okay, this is what I'm doing, and this is what other people are doing in a similar area, and here's how we compare. And coming into the corporate world, I found that this side is a little bit lacking. So I'd like to lead by example, and in my talk, I'm going to give my solution, but you also find that there are lots of other solutions, and some of them even existed 20 years ago. And maybe some of them, maybe you have used. And so I'll give you a few elements of comparison so that then you can get a good idea of what you want to invest in or what you want to compare. And especially in that light, my key phrase is use the right tool for the job. If during this talk you see that the tool isn't what you need, that the problem that I'm trying to solve isn't your problem, then please feel free to disregard everything I said and not use it. Please do not try and force the solution that I'm going to propose into your problem if it doesn't fit. So let's have a little closer look at that problem. Microservices. Microservices are great. People who do microservices have a smile 24/7. Why? Because there are a lot of advantages to microservices. There's separation. We can separate the problem, we can divide and conquer, and we can solve it as several teams that are working with autonomy. Microservices has a prerequisite, which is automation. Automation is actually good for the monolith, but we don't necessarily feel the need to automate our delivery when we're only doing it every 6 months. Whereas when we're in microservices, and we might be delivering 10 microservices every second, you definitely need automation. And so it kind of pushes you to automate, which is a good thing in any circumstance, as a lot of talks have touched on in this conference. It also enforces modularity. As we'll see later, the boundaries are very well defined in microservices. It helps to scale because you can scale parts of your application at different rates, whereas when you're in a monolith, it's ×2, ×3 of the whole monolith. And one of the advantages that I don't think gets enough talk is that microservices ease tech transitions. If you have a monolith, and it's written in struts and some ORM framework from the early aughts that isn't Hibernate or any of the cool new frameworks that there are out here, and you want to migrate that monolith to some of the cool stuff that you have today and get that smile back. Well, you almost have to shut down the project for 3 to 6 months just to refactor the whole monolith and get it working on the new stack. If you have a microservices architecture, you can start with the smallest microservice, the one that has the least impact, change that one, take you a few weeks. Get some feedback, adjust, adapt, and then push that through the other microservices. And slowly but surely, you can transition. So that's a good advantage to keep in mind. Now, on the flip side, microservices has a price to pay. And again, if you aren't willing to pay that price, do not go to microservices. It's not a black and white situation. It's not monolith is the enemy, and microservices is the solution to everything. In some situations, you should stick with a monolith. And in fact, other people, like Martin Fowler, say that when you start with a new project, it's probably better to start with a monolith to gain understanding of your domain, and then to split it up into the microservices that you will discover. So, what is the price to pay? Well, microservices has more complex integration. One of the reasons is that in a monolith, when service A calls service B, they're either both up or they're both down. But in microservices, you could have service A up and service B down, or the opposite. And you have to deal with that situation. So there are lots of things that are in place, circuit breakers, repeaters, and various options that you have, but you have to address that problem. You have to pay that price. Another price to pay is a decision between consistency and availability. You can't have both. And finally, another price to pay that I'd like to underline is that there are very hard boundaries in microservices. Whereas in a monolith, you couldn't hide obscure calls between 2 different modules, and it'll work. At one point, you'll discover it's technical debt, but it will work. Whereas if you try and call a microservice, an internal API of a microservice, it isn't going to work, because its public API is the only input that you can act upon. But let's face this, microservices are still cool. You know, let's not go too much into the disadvantages. Microservices are cool, you know it, all the young people are doing it, and everybody's smiling. Am I right? Back-end microservices are cool. And front-end microservices? Well, actually, the client side is still a little bit more like that. Let's be honest. Okay, your front end may not be quite as hairy and awkward as this guy, but he's still a monolith. He may be modular, but he still has to be deployed as a whole. We have come a long way. We've gone from entirely monolithic solution, and progressively, we've gotten to microservices in the back end, where we have a front-end layer that is calling each of the services through an aggregation layer. There are various options for that. And on the back end, we have services that are centered around business capabilities. So what I like to do is to give you a glimpse into some of the solutions we could have to actually complete the transformation and to have microservices full stack. Now, this isn't just for fun. There's an actual problem that we're trying to solve, that I'd like to solve with that I think this solves. This is a means. Full stack microservices is a tool. It's not the end. What is the end? What is the issue? The issue is how to build a large product with entirely autonomous, multidisciplinary teams. If you don't have this issue, then please do not implement the solution that I'm going to present today. But if you do have that issue, then please listen. I propose that we need to have full stack microservices and therefore accomplish this goal, this organizational goal, this business goal. I think that we need two things. We need a tech solution, which I propose would be distributed web components, and an organizational solution, which I propose to be atomic design. So we're going to look at some of the other solutions that are on the market. As I said, I'm going to compare myself to some other solutions. Some have been existing for 20 years. I'll give you a brief overview of web components. I'll give you a brief overview of atomic design. I'll give you lots of references so you can then get documented further if what I present interests you. And then finally, we'll bring it together with an example of full stack microservices and how that would work from a technical point of view, but also how it would work from an organizational point of view. Because in the end, it's not just a tech solution, it's also a business issue. So micro front ends, there's a website already up. It's been up for quite a few years, actually. And it's a term that was coined by some people there on this website that you can go look at later. And this is the goal that they propose. There are various different solutions, and it's a shame that some of them aren't shown, but you'll have the slides up on Twitter and the video later. There's Project Mosaic from Zalando. Who knows Zalando? Are people clients of Zalando to get their clothing? No? Okay. Well, they sell clothing over the internet, apparel more generally. And they have come up with a whole stack, a whole bunch of different tools that integrate together to do front-end compositing. Each microservice can contribute little bits of the UI, and then there's a definition of the whole app as an aggregation of all those pieces. And the key is that each team can deliver separately from the others. There's also another company called OpenTable, and they have their own solution, Open Components. And what's really interesting with this solution is that it's pretty much an API of UI components. You call with a REST API, and you get HTML back. Canopy Tax have a slightly different approach with their meta framework. They have the problem of compositing various different frameworks, Angular, Vue, React. Each team being able to work on what they want. And they need to composite that into a single SPA. And so they have a project called Single SPA that does that. And there's a really cool demo, example demo of just a hodgepodge of different frameworks and solutions that all fit together and live happily in the front end. And finally, I think this is the most important reference in this area. There's a guy called Gustav Nielsen Kotter, I hope I'm pronouncing that correctly, who has a lot of articles and a lot of experience on doing what he calls microservice websites. Microservice websites are scalable development of an evolvable system with great mobile performance. So he has some perspectives and some goals that may not be yours, which are performance, and the fact that to gain autonomy, you also need to have heterogeneity and scalability. So he's written a manifesto, he's written an article, and the article exposes a few different tools that already exist, actually. We're talking about edge-side includes, client-side includes, and caching with tools like Varnish. And he gives a good number of key tools, key issues to look at to properly implement efficient microservice websites. Now, there are other options that have existed for many years. Who hasn't written a JSP or ASP.NET fragment, or Ruby, and then try to include them up to make an interface? What about a JSP tag library? This is all tools to refactor our UI and to deliver it, to be able to change it in a modular way. Struts tiles, a little bit further on that line. And then let's leave the Java, maybe C# ecosystem, and you've got portlets. Portlet frameworks, very cool way to deliver bits of the UI independently. And finally, please don't laugh. I said no. iframes. No, seriously, iframes. Don't use them. But yes, they are a solution to autonomous composite UIs. What I'd like to offer are web components. And if you don't know web components, here's a quick sum up of what they are. Web components are reusable modular components for the web. There are it's declined in 4 specifications. It's W3C, and what you really need to know is that it's part of the platform. It is now just as bit of HTML as a div. It is in pretty much every browser. Here, I'll show this slide first. Pretty much every browser. There was a lot more red a few years ago on the Edge side, but suddenly they decided to develop it. There are 2 remaining specifications that they didn't have. And for the remaining time, you have a polyfill that you can load. So what does this look like? You can later go onto the code pen here and have a look. Maybe if I make this a little bit bigger, it might be a bit more readable. So I've got a small little project, and I'm just loading the polyfill, just in case you're on a browser that doesn't support web components fully. But that's the only thing. I'm using vanilla HTML, CSS, JavaScript. There's no React, no Angular, nothing like that. And I can use the 4 different specs to create a custom element. I extend an API that's in there. I've got a template for my element, bit of code, bit of CSS. I'm using something called Shadow DOM to hide that element. And then I'm using custom elements to declare my element. And all that is imported as a JS module and used in my UI as an element, just like as if it were a div. If you want to go more into the technical side of that, you can look at the code pen later. It's just an HTML element. It's got all the attributes, properties, events, styling. And it's compatible with all the frameworks you already use. Polymer, Angular, Vue, what have you, because it's part of the platform. And there are various frameworks and component libraries that can help you to develop web components faster, instead of just using the vanilla JavaScript that I showed you. Google are using them. Vardin have come out with some web components. And a cool new addition is Predix UI from General Electric. And they have a whole thing to integrate to make dashboards for IoT. Lots of other web components. I'll accelerate a bit so we can get into atomic design. Atomic design was invented by Brad Frost in 2016. He has a book online, free. You can go and read that. And he has come up with a methodology for creating and maintaining a graphic design system. He divides a UI into 5 different levels: atoms, molecules, organisms, templates, and screens. Atoms are the very smallest element, as the name suggests. It's really what is indivisible, and it's what gives the graphic identity. What colors you're going to use, what size of buttons, what text, what fonts. Those are the atoms that make up your UI. And then for the next levels, we're going to composite. We're going to bring bits together. Okay? And we're going to add purpose. We're going to give purpose to what we create. When we bring a button and a text box and a message that says search, well, that's a search box that can be reused across the UI. And from these different layers, we can come up with templates. Templates for our page, templates for our mobile UI. And then finally, when we composite the template with the data, we get the final page, the final product, that the user doesn't really notice that it's all from various little pieces. And it's all part of a system that's cohesive. So how do those two things mesh together to create full-stack microservices? Well, microservices and web components kind of have some things in common. We're integrating over HTTP. Web components are loaded over HTTP. We have lazy loading, and we have fault tolerance. If a web component doesn't work, well, it just doesn't show up on the page. There's not some big stack trace that's in the middle of the page. It's silent. Web components and atomic design have things going as well. And this is probably the most important part of the talk, so listen up. Atomic design is the methodology that's needed to develop a system of components efficiently. If you go out and say to all your teams, make web components, you're going to have a design that the user doesn't understand because one team's going to choose a slightly different shade of blue to another team. And there won't be a cohesive whole for the user. Atomic design is what's going to bring that to your web components. And we mustn't forget that there's not just the visual components, but also the internal components, the invisible ones like calls to APIs and state management. So this is what it would look like. You have a user that hits just a very thin router that just has a very thin front-end component. And that router is going to include a bunch of web components from various different pieces, various different microservices. And each of those small web components are going to be ways of calling and displaying information from those microservices. And you might also end up with shared components. You want a visual look and feel that is consistent across the whole thing. And so in the end, what you're going to have is probably something like this. You have a very thin router, you have your microservices, and you have shared components that are included by each of the web components of each of the microservices. And to tie that in with atomic design, well, we have to see where those different levels of compositing fit. Where are the atoms? Where are the molecules? Well, this is what I suggest, that the shared components are all the atoms, some of the molecules. the things that will be reused by everything. And then each microservice will define its own molecules, its own organisms, and its own templates. And the router, the thing that the user sees, the thing that's going to composite the whole together, will just be the pages, that is, the templates plus the data. So let's see if it actually works. Not sure if people at the back can see, but basically, I've got Eclipse. If you don't like Eclipse, it doesn't matter. You can do this in IntelliJ or whatever. I've got, in my example, which you'll be able to, there'll be links on GitHub, so you can run this, and you can actually see for yourself that it does actually work. I've got an edge with the router. With just a very thin layer of front-end components. That's all there is. I have two services, one that's a catalog that has the back end and the front end. So I'm using Spring Boot here and Polymer for the web components. And then I have an order service, which also has back end and front end. And that's a very small service, so I used Vertex. And here's what it looks like. We've got a shop. And so we've got a catalog in this shop. We've got items that we can buy. Say I want 5 Nokia phones, 3310s, because those are huge, all the rage today. And I've added them to my cart. I can go see in my cart. I have 5 Nokia 3310s, and now I want to buy something. And up till now, I've been in the catalog service. And now, when I want to place my order, well, that's the order service. So when I click on this button here, in fact, just the presence of that button, this credit card button, is another microservice exposing not just an API, but a UI. So when I click here, it's sending a message to the order server, to the order backend, and now I can flip to the UI page with the orders, and we're done. And then we have to ship that, but that's somebody else's problem. So to conclude, what have we gained? We gained a way to have fully autonomous teams that can work on the whole stack. The only bit of integration that we have is a very thin layer that just basically defines, okay, what is the user going to see? What's the composition of components and services that are going to be displayed to a specific user on a specific platform? We can expose APIs, developer APIs, developer keys, but we can also expose UI components. Who has ever wanted to embed a YouTube video? Yeah? And up until a few years ago, if you wanted to embed a YouTube video, the easiest way was to click on the little box, little button, and cut and paste the HTML code that would load some JavaScript and do all sorts of magic with the DOM. Now, there is a Google YouTube web component, and you can use it just like a Canvas component or a div. We can do rapid application development. One of the cases is Electronic Arts has ported all their websites. Electronic Arts has ported all their websites about their various different games to web components. And they can share web components even though the design of each game is completely different. And also one of the experiences, which I find it a bit hard to believe, is that they can bring up websites without a developer. Just the designer, he's got a catalog of web components, he styles them in the style of the game, and he's got a website that's promoting the game without even contacting a developer. Don't know if that's the full reality of it, but it means we're making good progress. And we have a choice of front-end framework. You can have web components defined in React that are included in an Angular app. There's also including Vue components. What's difficult? Or what are some of the pitfalls that you need to avoid? You need to be careful that that you aren't going to have strong coupling between the API and the UI. Now that you've got the UI that's being defined with the backend, there could be the evil of making them too tightly coupled. There's also the fact that library design is always much more difficult than application design. And what we're doing with these microservice websites is that we're actually defining a design system, something that's bigger than your website, and then instantiating it as your website. And so trying to design that system is going to be much more difficult than designing the website itself. And for the moment, it's a little bit difficult to isolate certain dependencies. The way I have it set up, if two microservices import the same dependency but with two different versions, they still need to be loaded, sort of like in the same class path, but in a JavaScript way. And so it could create conflicts. And there's still work to be done. And sorry, one of the things I'd like to point out is that why not have third-party services encapsulated at not just API, but UI. Thank you for listening. I hope there was something for you. And if not, you can always ask some questions to me afterwards.